Hi, my name is Courtney Bull, and today I'm going to be discussing my research project titled Does Müllerian Mimicry Evolve in a Punctuated Equilibrium? I'm going to begin by explaining two important concepts that are relevant to this project. The first is an anti-predator adaptation known as Müllerian mimicry. This is a form of defensive mimicry where many protected species evolve similar warning patterns, and by protected I mean they have a noxious taste. This type of mimicry is frequency dependent, meaning that the more mimics there are, the more protection is gained. This is because the predator will learn to associate the warning signal with a noxious taste, and therefore avoid consuming the mimic. The other important concept is the theory of a punctuated equilibrium, which is a theory of evolution that is quite different from the traditional Darwinian phyletic gradualism hypothesis. This theory was proposed in 1972 by Gould and Eldredge and describes a mode of evolution whereby we see long periods of stasis, meaning that we see little to no change. This is followed by bursts of rapid evolution following speciation events. This project aims to investigate if Müllerian mimicry evolves in a punctuated equilibrium or if it follows a gradual mode of evolution. If we look at figure 1, we can see two different phylogenetic trees, with A showing a punctuational pattern of evolution and B showing a gradual pattern of evolution. And B assumes that change is independent of speciation events, whereas A believes that changes follow speciation events. Müllerian mimicry is very well studied in butterfly species, particularly Heliconias. I decided to carry out my analysis on North American velvet ants because despite being one of the most speciose mimicry complexes known, North American velvet ants remain largely understudied. My hypothesis is that Müllerian mimicry does evolve in a punctuated equilibrium. We will observe a large percentage of the punctuated effect as the mimic makes mutational leaps towards resembling the model. This is followed by gradual evolution as the mimic evolves towards perfect mimicry, and then experiences periods of stasis as they don't want to out-evolve or evolve out of their protective colouring, as this will lower their fitness. In order to test this, I searched GenBank, which is a large gene database, and found gene sequences for ITS1, ITS2, and the wingless gene. Next, a sample of 1,000 trees with the highest posterior probabilities were inferred using a statistical method known as the Markov chain Monte Carlo method. Okay, so now we get to the exciting bit where we can find out if we observe the punctuated effect in our sample of 1,000 trees. So the equation x equals b times n plus g is used to test if there is a correlation between path lengths, represented by x, and the number of nodes, represented by n. Punctual contribution, represented by b, is estimated from the relationship between x and n. So to summarize, we are looking to see if there is a positive relationship between the number of nodes and the total path length. If b equals 0, we assume a gradual mode of evolution, whereas if b is different from 0, we assume a punctual mode. We need to test for an artifact of phylogenetic inference known as the node density artifact, which occurs in a tree with less nodes as it can underestimate the rates of change, therefore creating a relationship between x and n and making us think that there is a punctual effect happening, a punctuated equilibrium, when actually there isn't. So my analysis revealed that our data did not suffer from the node density artifact and did not show significant contribution of the punctuated effect in the evolution of Müllerian mimicry. And as a result, we reject the null hypothesis. And I believe that we found this result because North American velvet ants can be grouped into different mimicry rings based on colour patterns. The null hypothesis did not take into account this phenomenon, which may account for the gradual mode of evolution. As mimicry rings occur due to convergent evolution, which is a slow, continuous process. Furthermore, well-protected mimics would not want to evolve away from their protected colour patterns. As a result, we would expect the evolution of Müllerian mimicry to be gradual. Future studies should compare the evolutionary dynamics of Bachian mimicry as well, which is another form of defensive mimicry where a mimic is not protected but evolves to resemble a species that is protected. And I believe there is a possibility that as Bayesian mimics are more likely to make large mutational leaps towards the model, as they don't evolve in this mimicry ring. That's not to say that they can't evolve into a mimicry ring. And they make these large leaps towards the model and their mimicry rings. I therefore believe we may see a larger contribution of the punctual effect. The challenging part of this study was using velvet ants because there was not much data available. And I think that future studies may want to focus on using butterflies because there is more data available and therefore it would be easier to test such hypotheses.